Hello everyone, this is teacher Justina and welcome back to my YouTube channel. If you are new, then do not forget to subscribe, like and share, and do comment below. And do not forget to hit the notification bell for more video updates. Our video for today is all about an ellipse. Ellipse is one of the conic figures. Okay, so let us explore. So what is an ellipse? An ellipse is a set of points in the plane such that the sum of the distances from two fixed points called foci remains constant. Okay, so it is the ellipse can be formed when the double right circular cone, as it is being presented in the figure below, is cut by the plane. So as you have seen the plane in there, so that the angle between the plane and the axis greater than the vertex angle, and then that ellipse as a conic figure is obtained. Okay, so let us now go to the different standard form of equations of an ellipse. So what will be the equation of an ellipse if its center is 0, 0, or the center is in the origin? So as you have seen, this ellipse is horizontally oriented. So when we say horizontally oriented, the major axis is horizontal. And then if you are to refer it to the equation, uh, where's the a squared in the equation, there is the greater denominator or the bigger denominator. So in this case, the a squared is the bigger denominator and its numerator is x or x squared. So meaning your uh, ellipse will be horizontally, or the orientation of the major axis is horizontal, because the bigger denominator falls on the x squared variable. Okay, so it is always equated to 1 because it is being mentioned that it is the sum of the two distances. So the sum of the 2 points, which is remains constant. So it is always equated to a constant 1. Okay, so what will happen to this equation and what is the orientation of this? So far, as you have seen, the major axis, okay, is vertically oriented. That means that our major axis is parallel to the y-axis. So if we are to refer it to the equation, uh, where's your a squared? Yeah, there is your a squared here, and the numerator of your a squared is y squared. That means that your ellipse is vertically oriented. That means the major axis is parallel to the y-axis, or in other words, the y-axis itself is your major axis. Okay, and now let's proceed to the third figure. As you have seen, our center is no longer the 0, 0, or it's no longer the origin. So if you have seen in here, the origin, I'm sorry, the center is other than the 0, 0, and it is being represented by hk. That's one. So the h is a constant, it's a horizontal distance, while the k is a vertical distance from the origin. So that means that our a squared is a denominator where your numerator x is present. So that means our ellipse is horizontally oriented, but our center is not the origin anymore. Okay, what about this second or the fourth figure? So the fourth figure is uh, still the center is not 0, 0, but other than 0, 0, or it can be found on the uh, any of the four quadrants. So this given is it's on the second quadrant. So still, if we are to refer it to the equation, our equation is the a squared is found uh, below the y minus k squared, meaning Our major axis is vertically oriented. So as you have seen, our major axis is parallel to the y-axis. So that's it, parallel to the y-axis. So let us now familiarize the different fundamental elements of an ellipse. So what is a foci? The foci is said to be, or the fixed points of the ellipse, which are located on the major axis. So far, these are the two focus, or the plural form of focus is foci. And then, let's proceed to the major axis. So what do you mean by major axis in an ellipse? It is the longest diameter of the ellipse and pass through the center. As you have seen, it is being mentioned in there that the longest diameter of the ellipse. So it is being pointed in here that this dashed line, which is horizontally drawn, is our major axis. Okay, so if you are compare this to the vertical dashed line, this is bigger, or not bigger but longer than the vertical one. So it is the major axis, while the minor axis is the shortest diameter of the ellipse. So this one, the vertical dashed line, is the minor axis. So it is shorter than, of course, to the minor axis. Then the next one is the center. The center is the point of intersection of the minor and major axis. So when we say center, this one is said to be the center, and this is the intersection of the minor and the major axis. And then the focal length. Okay, when we say focal length, it is the length from one focus to the other. So this is the focus 1, followed by the focus 2. And then if we will be connecting the two foci, then it is said to be the focal length. Then let's proceed to the vertices. The vertices are the points of intersection of the ellipse with the major axis. Okay, so the vertices again are the points of intersection of the ellipse with the major axis. So when we say vertices, so we have this vertex 1 and this is vertex 2. And where should the two vertices lie? So the two vertices lie on the major axis. Okay, so what about the other two endpoints here? So these two endpoints here that is drawn vertically are said to be the co-vertices. So the two endpoints are said to be co-vertices. It is the points of intersection of the ellipse with the minor axis. So this one, this is the curve of an ellipse, and these two points are the intersection of the minor axis with the ellipse. Then let us now familiarize the semi-minor axis, or the semi-minor axis, and the semi-major axis. So the semi-minor axis is of course half of the minor axis. So when we say half of the minor axis, this one is half of the minor axis, then it will be one semi-minor axis, and this is another half of the minor axis. While the semi-major axis, or the semi-major axis, is of course half of the major. So from this vertex to the center is half of the major axis, and the other half of the major axis is from the center to the vertex. Okay, so let us try these examples. Determine the center, the vertices, the co-vertices, the foci, the length of the major and the minor axis, and also sketch the graph. So the given equation is x squared over 9 plus y squared over 81 is equal to 1. Okay, step 1, we need to check which denominator is bigger. So 81 is bigger than 9. So therefore, if 81 is bigger than 9, thus we have to look for the numerator. So the numerator of 81, which is the bigger denominator, is y. So if y is our numerator, thus we will be having an ellipse which is vertically oriented. So when we say vertically oriented, meaning our major axis is parallel to the y-axis. So let us try get the center. So the center is 0, 0. Then we have to plot it. Okay, next is we need to get the length of the major axis. So how to get the major axis? So we have known that our ellipse is vertical and parallel to y-axis, and we need to find the length of the major axis, which is described by the formula 2a. And where is that? What is that 2a all about? That means we will be multiplying 2 to the square root of our a squared. So we're in it's 81. So 2 times the square root of 81 is equal to 2 times 9, then it is equal to 18. So when we say 18, so that will be the total length. So this is the total length of our major axis. So if this is the total length, that means our ellipse major axis is vertical or parallel to the y-axis. That means we need to count 9 units up and also 9 units down. So that's it. So it will be 9 units down and 9 units up, and for that our vertices coordinates are 0, 9 and 0, negative 9. Okay, and we need to connect the two endpoints or the two vertices of our major axis, and there is our major axis. So this is our major axis already. So next we are to determine the length of our minor axis. So our minor axis is described by the formula 2b. So that means we have to multiply 2 to the square root of our b squared. And our b squared is represented by 9. So the square root of 9 is 3. So therefore, that 6 is the total length of our minor axis. So if our minor axis is horizontal and parallel to x, that means that 6 units is, we need to count from the center 3 units, right? So 1, 2, 3, and 1, 2, 3 left and right 3 units. Okay, so there are the two endpoints of our minor axis. And to connect uh, the two co-vertices endpoints, so we have already our minor axis. Okay, and then how do we determine the focus? So the formula for the focus will be c squared is equal to a squared minus b squared. That means that we are going to subtract the bigger denominator minus the smaller denominator. And our a squared is 81 while our b squared is 9. So therefore, getting the c, we need to get the square root of 72. So 81 minus 9 is 72, and that will be approximately 8.49. So if our focus is 8.49 units, that means we need to count from the center. So that will be from the center 1, 2, 3, 4, 5, 6, 7, 8, approximately 8.49. So it is in here. Okay, so that's it. And going up 8.49 units, 1, 2, 3, 4, 5, 6, 7, 8, and that will be uh, in there. So therefore, how do we determine the coordinates of our foci? So it will be represented by the coordinates 0 and 8.49, and in here we have 0 and negative 8.49. Okay, to completely sketch our ellipse, thus we have to have the smooth curve, and this curve passes through the vertices. When we say vertices, they are the endpoints of the major axis, and also it passes through the co-vertices. So when we say co-vertices, they are the endpoints of our minor axis. Okay, how do we know if our graph is correct? We will be choosing a point on it. So that will be represented by the coordinates 2 and 6.73. So we will be using the original equation So the original equation is x squared over 9 plus y squared over 81 is equal to 1. So the x squared, they represented by 2 squared over 9 plus 6.73 squared over 81. Is it equal to 1? Okay, so to further simplify, so 4 over 9 plus 6.73 squared is equal to 45.3 over 81. Are they equal to 1? Okay, so 4 over 9 is 0.44 approximately, and 45.3 over 81 is approximately 0.56. And of course, 0.44 plus 0.56 is equal to 1. Therefore, our graph is correct. Okay, so that's it. Let's proceed to the second example. X squared over 36 plus y squared over 16 is equal to 1. Okay, of course, our center is 0, 0. So we are done plotting it. Okay, next is our major axis is, so which is our bigger denominator? It's 36. So if it is 36, so that will be, this will be our a squared and this is our b squared. So to find out our length of the major axis, so that will be 2 times the square root of 36. That will be 2 times 6, thus it will be 12. So therefore, our major axis length is having a total of 12. And since it is horizontally oriented, why horizontally oriented? Because the 36 is bigger than 16 and the numerator of 36 is an x variable, so therefore our major axis is parallel to the x-axis. And since it is 6 units from the center to the right and 6 units from the center to the left, so that's it. They are the endpoints of our major axis or the vertices. So again, the vertices are only found on the major axis, while the co-vertices are only found on the minor axis. Okay, to connect the two vertices, okay, that's it. So therefore, we have our major axis, and let's proceed to the minor axis. So our minor axis is coming from the smaller denominator, so therefore it will be 2b. Okay, and 2 times the square root of 16, which is 4. So that will be 8 units. So overall, length of our minor axis is 8. And that means our minor axis is vertical or parallel to y. That means we need to move 4 units up and 4 units down. Okay, so far we have from the center 1, 2, 3, 4. 1, 2, 3, 4, and there are your the co-vertices. So when we see co-vertices, it lies on the minor axis. Okay, so to completely have the minor axis, we need to connect the two co-vertices. Okay, what is the next is to find the focus. So the focus is 4.47 and 0 and negative 4.47 and 0. Why? Again, the focus formula is c squared is equal to a squared minus b squared. And our a refers to the bigger denominator, which is 36, minus our b. So b squared is already 16. Okay, so therefore c squared, what is 36 minus 16? That will be 20. And what is the square root of 20? The square root of 20 is 4.47. So 4.47 is the number of units from the center going to the this 4.47. So again, the focus should lie on the major axis. It's not on the minor. So count 1, 2, 3, 4. So since it is 4.47, that is somewhere there. And the other one is, let us try. 1, 2, 3, 4.47, and that's it. 4.47 and 0 are the coordinates of the other focus. So then we need to sketch the curve of an ellipse. Okay, so therefore, that's the sketch of the ellipse described by the equation x squared over 36 plus y squared over 16 is equal to 1. Okay, guys, I hope you've learned something from my video today. And if you want to learn more, do not forget to subscribe and do comment below for more video updates. This has been Teacher Justina, and thank you for watching. That in all things, God may be glorified. Thank you. Goodbye, everyone.